Hello, curious people! Now, this video is going to discuss a math mistake I saw in the movie. I'll explain it to the best of my ability. However, before we dive into it, here's the total video length so that you have a bit of an idea what you're getting yourself into. Still here? Excellent! Let's begin. So, a few months ago, I've stumbled across this compilation of clips from the movie Boss Baby Family Business. It was trying to showcase how smart a character called Tabitha here was by having her seemingly get a lot of school questions right. However, she seems to have made a math mistake that even the teacher didn't notice.
X is equal to the derivative of...
me itself.
Kudos for Tabitha.
The teacher asked Tabitha, X is equal to the derivative of... To which Tabitha responded, itself. Yet even though Tabitha was marked right by the teacher in the movie, she actually got it wrong. X is not the derivative of itself. To see why, we need to take a look at what the derivative in calculus actually represents. Don't worry, I'll try and explain it as simple as I can. If we have a graph of a function, like y equals x squared as shown here, the derivative essentially tells us what the slope of a graph is at any particular point, like this green point I labeled here. It would be easier to define the slope if we had the graph of a line, but for curves like this, it's a bit trickier. Here, the derivative represents the slope of this orange line, tangent to the red curve at the green point. So here's the red curve, this is the orange line, it's tangent to the red curve, exactly at the point of interest. Now, one way to figure out the slope of the tangent line is to first plot another point on the curve here in purple, and then find the slope of a secant line, or in other words this line here between the green and purple points, and then bring the purple point closer and closer to the green point while keeping track of how this slope, the slope of the secant, changes. For nice functions, like in our example, this purple line seems to be approaching the orange tangent line. So as these points get closer together, the slope will approach the derivative that we would like as you could see over here. And now, in this case, the slope of the orange line seems to be about double of our input of a green point, because our green point has x-coordinate 0.6, and currently we're at 1.37, and it's going to get closer and closer to 1.2. And in fact, this is actually the case for all points on our x squared graph. And so, the derivative of x squared is 2x. To make this concept more formal, we would usually use the limit definition of derivative taught in calculus classes. Now, going back to Boss Baby. Okay, so as we've discussed earlier, the derivative of a function like y equals x over here represents the slope of its graph here at any particular point. Tabitha said x, this graph, is the derivative of itself. But here we can see that the graph of y equals x is actually a straight line with a constant slope of 1. So, therefore, x is not the derivative of itself, because the derivative or slope of a graph y equals x, as shown here, is 1, regardless of whatever input x we choose. Over here, the slope is 1. Over here, the slope is also 1. Regardless of what input x we choose, the slope is 1. So unfortunately, Tabitha got it wrong. Though, in fact, based on what we saw earlier, we can actually somewhat find out what the right answer should have been. the rest of this probably already long video would do just that. Okay, so remember how over here we noticed that the derivative of x squared was 2x because the slope of this tangent line was twice the input of our original green point? Well, what if we multiply this x squared by a constant factor of 1/2? How would this affect things? Well, if we multiply our old function x squared by the constant factor 1/2, this had the effect of squishing our function and its corresponding slopes by that exact same constant factor. And so, since the slope of the orange line used to be double the input of a green point, once we halved the slope, we should get an exact match of a green point's x value. And thus, x would be the derivative of our modified function, 1/2 x squared. Although, while this does work, this is not the complete answer just yet. That is because we can actually shift the graph of our function up or down. So up or down, like if you move it up or down, it's not going to affect any of the slopes of the tangents whatsoever. So, this will result in adding an arbitrary constant, which we usually call c, to our new function. As you could see, regardless of how we shift the function up or down by adding my arbitrary constant c, the slope of a tangent line in orange never changes. So, therefore, the final answer to the question is
x is equal to the derivative of
1/2 of x squared plus an arbitrary constant, c. That is the correct answer that the writers should have made Tabitha say. Although, we really cannot be too harsh on Tabitha. After all, she is a second grader, so most of this is probably going to be way above her level anyway. Still, I hope that anybody who's already made it this far, all the way to the end, enjoyed this brief glimpse of calculus brought to you by Tabitha's Goof Up. Stay curious, everybody!